Hi students. At this point, we have learned several different factoring methods. We have pulled out the greatest common factor, we've done factoring by grouping, we've looked at unfoiling, we've used the AC method, we have factored special forms, and right now we're at the point where we need to start thinking about when we use each of these methods. Now, I have a handout that I give to students when we talk about choosing factoring methods. I hope that you have printed that out. I'm not going to display it on this screen because the handout is actually larger than this screen, so it would take up a lot of space. So instead, what we're going to do is we're going to go through a few examples, and we're going to talk about how we make the decisions based on what the handout says. So if you're one of my students, hopefully you have printed out the handout. If you are someone else's student who found your way to this video, hopefully you'll be able to understand how we're going through this just by me walking you through these things step by step. So let's take a look at a problem and we will talk about how to approach it. So let's factor 5x to the fourth minus 20. Now, whenever we're factoring a polynomial, the very first thing we need to do is factor out the greatest common factor if there is a GCF that can be factored out. This is the golden rule of factoring. Always start with a GCF. And in this case, there is a GCF that we can pull out. The GCF is 5. So we pull out a 5, and then we're left with x to the fourth minus 4. Once we've dealt with the GCF, the second step is to choose a factoring method based on the number of terms left over. So if we look at the leftovers here, we've got x squared minus 4. There's 2 terms there. And the only factoring method that we covered that works with 2 terms is a difference of squares. So we need to ask ourselves, is this a difference of squares? And in this case, it is. X to the fourth is x squared squared, and 4 is 2 squared. So we can break that down. We leave the 5 out front, and when we use the difference of squares, this becomes x squared plus 2 times x squared minus 2. Then the last step is to check to see whether any factors can be broken down any further. And in this case, they can't. This might look like a difference of squares. However, 2 is not a perfect square, so nothing can be broken down any further, and this becomes our final answer. Let's take a look at another one. Let's factor this time 4x squared minus 8x minus 60. We're going to follow the same steps here that we did in the last one. First, we always have to check to see if there's a GCF that can be pulled out. In this case, there's a GCF of 4. When we pull out the 4, we're left with x squared minus 2x minus 15. After we've pulled out the GCF, the next step is to look at how many terms we have in the leftovers and use that to choose a factoring method. Now, there are 3 terms here. We have a trinomial, and there's a couple of possibilities we had for trinomials: unfoiling and the AC method. Do you remember how to choose between unfoiling and the AC method? In this case, we use unfoiling because the first term, x squared, doesn't have a leading coefficient. If it did, if it was 2x squared or 3x squared or 8x squared, we would use the AC method, but because there isn't, we use unfoiling. So we're going to leave the 4 out front, and we want to unfoil this. So we're looking for 2 numbers that have a product of negative 15 and a sum of negative 2. Those numbers end up being -5 and +3. So in the parentheses, we have x minus 5 and x plus 3. None of this can be factored any further. So that means our final answer is 4 times x minus 5 times x plus 3. All right. Let's take a look at a couple more examples. Let's do 9z to the 5th minus 9z. Again, we're going to start by looking for a GCF. And in this case, we can pull out 9z from each of those terms. When we do that, we're left with z to the 4th minus 1 as our leftovers. Now, we want to see how many terms there are here to choose a factoring method. There's 2 terms, and the only possibility for factoring a binomial is a difference of squares. This does happen to be a difference of squares. Z to the 4th is z squared squared, and 1 is 1 squared. So when we factor that, we leave the 9z out front, and then in parentheses we have z squared plus 1 times z squared minus 1. Now, the last step is to check and see if any of these can be factored any further, and there is one factor that we can break down even more. Can you see which one it is? In this case, it's the last one, z squared minus 1, because it is a difference of squares. Z squared is z squared, and 1 is 1 squared. So we're going to leave the 9z alone, and we're going to leave the z squared plus 1 alone. That's actually a sum of squares, so we're not going to break that down. And then z squared minus 1 breaks down into z plus 1 times z minus 1. And we're finally at a point where we can't break anything down any further, so this is our final answer. All right. Let's do one more problem. Let's factor. And this time we're going to look at 24r cubed plus 8r squared minus 2r. Again, we're going to start by looking for a greatest common factor that can be pulled out. And in this case, there is one. All of those terms are divisible by 2r. So we're going to pull out a 2r, and that leaves us with leftovers 12r squared plus 4r minus 1. Next, we need to look at these leftovers and determine which method to use next, and we base that on how many terms there are. There are 3 terms here, and so there are 2 options for factoring a trinomial: unfoiling or the AC method. Which one should we use here? Well, in this case, we're going to use the AC method because we have a leading coefficient on the r squared. If it was just r squared without another leading coefficient, we could use unfoiling. But because there's a leading coefficient other than 1, we have to use the AC method. Now in this case, a times c is 12 times -1, which is -12, and b is 4. So we need 2 numbers that have a product of -12 and a sum of 4. Those numbers end up being 6 and -2. So we need to split that middle term using 6 and -2 as the new coefficients. But also, we've got this GCF out front. This is a little bit more complicated than what we've seen before, and there's something I like to do in this situation. We're going to keep that GCF out front, but I'm going to change these parentheses to brackets. The reason I'm doing this is because as we go through the AC method, we're going to end up with more parentheses, and I don't want to confuse those parentheses with the ones that we start with, so it's just a little bit nicer to change those parentheses to brackets. Now let's use the AC method. When we split up that middle term, we get 12r squared plus 6r minus 2r minus 1. And then we can use grouping inside. We're going to keep that 2r out front. The GCF is always going to stay out front. It's never going to move. It's never going to leave. Now with grouping, in the first group, those two terms have a 6r in common, leaving us with leftovers 2r plus 1. And then in the second group, we can pull out a -1 to also leave us with 2r plus 1. And we're happy because we have the same thing inside each of those parentheses. So, keeping that 2r out front, now with the grouping, we can put the GCF out front, so that's 2r plus 1. And the leftovers in the back, 6r minus 1. And with our final answer, we can actually get rid of these brackets, because at this point, everything is multiplication. 2r times 2r plus 1 times 6r minus 1. These brackets don't do anything special, and so we can write our final answer as 2r times 2r plus 1 times 6r minus 1. There are no more factors that can be broken down any further, so this is our final answer. With all of these problems, we're following the same strategy for factoring them. The first step is always the GCF. If there's a GCF that we can pull out, we want to start there. Then the next step is to look at the number of terms and use that to pick a factoring method. If there's 2 terms, we can only do a difference of squares. If there's 3 terms, we have to choose between unfoiling and the AC method. And when there's 4 terms, we use factoring by grouping. And then once we've used a method, the last thing we have to do is check to see if we can factor more. If there's anything that can be broken down even further, like a difference of squares, we want to make sure that we do that. Otherwise, we're done. I want you to definitely get a lot of practice. Go through all of the examples in the link below, because there are so many different possibilities, and the more practice that you get, the more comfortable you'll be factoring these polynomials without having to go back and consult your notes.